Here we have a problem involving geometric sequence and geometric series together. It says the second term of a geometric series is negative 30. The sum of the first two terms is negative 15. Find the first term and the common ratio. So we need to find u1 and r. Well, first things first. The geometric sequence formula is un equals u1 times r to the n minus 1. And the geometric series formula is Sn equals u1 times the quantity 1 minus r to the n, all divided by 1 minus r. So if we know that the second term of the series is negative 30, we can say, well, here is our sequence. u2 is equal to u1 times r to the n minus 1. If we're finding 2, it's 2 minus 1. So we know that u2 equals u1 times r to the 1. And it says that the second term is negative 30, so we can consider that a sequence. u1r is equal to negative 30. And the sum of the first two terms, now you're thinking series. When you see the sum of, you're thinking series now. The sum is negative 15. So u1 times 1 minus r squared all over 1 minus r is equal to negative 15. I have this red equation here and this blue equation here, and now I can combine them. Now that we have our two equations, u1 equals negative 30 over r, and u1 times the quantity 1 minus r squared divided by 1 minus r equals negative 15, I can solve this for u1, divide both sides by r, and I get u1 equals negative 30 over r, and then substitute every time I see a u1. So instead of u1, I write negative 30 over r because they are equal. And now I can start to simplify. I distribute this out to both of these terms in this binomial expression, and I get negative 30 over r plus 30r, all divided by 1 minus r is equal to negative 15. At this point, I can multiply both sides of the equation by 1 minus r, and then distribute the 15 on the right-hand side out to the 1 and to the negative r. At this point, I can then multiply, I have an r in the denominator. If I multiply each and every term by r, I will cancel my r's in the denominator, and I'll get negative 30 plus, now it's r times this gives me r squared, now it's r times this gives me negative 15r, now it's r times this gives me 15r squared. When you have r squareds and r's and numbers or constants in one equation, you want to throw everything to one side. So what I did is I added 15r to both sides. I subtracted 15r squared to both sides. So if I subtract 15r squared from both sides, 30r squared minus 15r squared gives me a positive 15r squared. And I had this minus 30 already. I factored out a 15, so I got 15 times r squared plus r minus 2 because I saw 15 was common to all three of them. And then I divided both sides by 15 to give me this expression. When I got this expression, I factored. I can use the zero product property to set r plus 2 equal to 0 and r minus 1 equals 0, giving me the common ratio of negative 2 or 1. So I've got to investigate both of these because I found I have two common ratios. At this point, we see we have two possible values for r, the common ratio, negative 2 and 1. Well, earlier we found out that u1, or our first term, is equal to negative 30 over r. So let's try r is negative 2. When r is substituted with negative 2, we get our first term is 15. Well, if r is negative 2 and our first term is 15, that means 15 times negative 2 is negative 30, times negative 2 is 60, times negative 2 is negative 120, and this will go on and on and on. Does that meet the conditions that we're supposed to satisfy? Meaning the second term is negative 30. Yes, our second term is negative 30. The sum of the first two terms is negative 15. Yes, 15 minus 30 is negative 15. Conversely, let's try r is equal to 1. Well, our first term is equal to negative 30 over r, and we substitute 1 in for r, and we get our first term is negative 30. Well, if r is 1, then our terms go negative 30 times 1 is negative 30 times 1 is negative 30, and this will also continue forever. Does that meet our conditions that the second term is negative 30? Yes. Did the sum of the first two terms is negative 15? No, the sum of the first two terms here is negative 60. So this can't be the answer, and this is the answer. meaning our common ratio is -2, our R is -2, and our first term is 15. We've answered the question now. A woman invests $1,000 at the beginning of each year in a superannuation scheme. If the interest is paid at the rate of 12% per year on the investment, and that's compounded annually, how much will her investment be worth in 20 years? We know that this is a geometric series and we can use our formula for that. The question becomes, what is R? Well, 12% per year means 100% of our investment plus 12 more percent. So our R is 1.12. We know it's got to grow, so it's got to be bigger than 1. The question then becomes, what is U1? Well, U1 is $1,000 at the beginning of the year, so that's $1,000. The real question becomes, how many years are we going to do this for? Is it 19 or 20? 20 years means we take 19 jumps. Well, let's take a look here. This is what happened 20 years ago. She invested $1,000 at 12% interest, and she's going to get that bump 20 times. This is what happened 19 years ago. She invested $1,000 at 12% interest, and she gets that 19 times, etc., 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 all the way down the line until we come to a year ago, where she invested $1,000. Say she invested this on January 1st, and now it's December 31st. She's gotten a whole year, that one whole year of investing. So she got this year, 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 all the way down until she got this year. So with these numbers here, you can see, if we set it up like this, the woman has received 20 years of benefit at 12% interest. So that would mean that, yes, you could certainly write it all out like this and get your answer, or you could simply do a geometric series. Our U1, or our first term, is 1,000, times 1 minus R, which is 1.12, to the N. Our N here is 20, divided by 1 minus R, gives us 80,698.74. This is a tricky problem, but you have to understand that in this black numbering here, 1,000 times 1.12 to the 20, she has received the benefit of that investment for 20 years. All the way down to, if it's December 31st right now, and she invested that $1,000 this year on January 1st, she's gotten the benefit of this money too, getting the bump from the investment at 12%. So you can see, if you count the numbers up, she's gotten the benefit of that, the benefit of this 12% interest 20 times. So that includes our 20 years later. A family decides to save some money in an account that pays 9% annual interest. If you have 9% annual interest, then your base will be 1.09, because you have to multiply by 100% plus 9%, which is a decimal, is 1.09. So it pays 9% annual interest, and that's calculated at the end of each year. All interest is added to the account and no withdrawals are made. How much money will this family have in the account on the day after they have made their 10th payment? Well, if you make 10 payments, then you're going to have 9 jumps between the 10 payments. So the amount in the account will be, you could really think of this as working backwards. The amount in the account the day after the 10th payment will be, well, they made this payment yesterday, $2,500, plus the one they made last year, which was $2,500, times it's paying 9% interest, 1.09. You only get that for 1 year, so our 1 is our exponent. Plus the one they made 2 years ago, which is $2,500, they put in the account times 9% interest, which is 1.09 squared, because it was 2 years ago. Now, and so on, 2,500, 1.09 to the third, 2,500, 1.09 to the fourth, 2,500, 1.09 to the fifth, to the sixth, to the seventh, to the eighth. This is the one they made 10 years ago, 9 jumps ago. Well, when you total all of this, it comes to 37,982.32. Again, the key is to start backwards. Yesterday they put 2,500 in. A year ago they put 2,500 times 1.09 to the 1, etc., and work all the way back until you have 9 jumps. Because we have 10 payments, we're going to have 9 jumps. Alternatively, you can look at this as a geometric series. if we look at this same data, we could interpret it as a geometric series. Here is 2500. 2500, 1.09 to the 1. 2500, 1.09 to the 2. 2500 times 1.09 to the 3, etc. All the way up. We have 10 different terms, and we take 9 jumps. Well, that can be looked at as if this is your U1, your common ratio, meaning this divided by this, and this divided by this, and this divided by this, and this divided by this, is 1.09. And so let's just plug in 1 minus the common ratio. To the end, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms, because we made 10 payments over 1 minus r. So it's important to know these formulas and be able to plug in. This is just your common ratio. This divided by this is the same as this divided by this, is the same as this divided by this, is 1.09. And we're raising it to the 10th power because we have 10 terms. This will also give you that same answer, 37,982.32 cents.